This is the grade 12 mathematics paper 2 of the NSC DBE November 2022 paper, question 10, which deals with Euclidean geometry. If I'm not mistaken, it's also the last question of this paper. So by this time, I might be very, very sleepy. Or not. Okay. Question 10. It's this fantastic looking thing. Rearrange it a little bit. There we go. All right. Information given. PQRS. PQRS is a cyclic quad. KP is a tangent to the circle at P. So KP here is a tangent to the circle at point P. C and D are points on the chords PS and PQ, and CD produced. Produced just means straight line to meets RS, which is produced at A. Okay, so just those are all just telling you that it's straight lines. So let's take a look. It says, first prove giving reasons 10.1 that angle S1 equals angle T2. So let's find S1. We need to prove somehow that that is going to be exactly equal to T2. Okay. This one, oh, not a fun question to work through. So the first thing that I noticed is that it was given, I always try and start with the information given. So it was given that PQRS is a cyclic quad. So that means that S1 is going to be equal to the opposite interior angle, the external angle of the cyclic quad. This is produced to A, that RS is produced to A, that means it's a straight line, so it meets the criteria of a cyclic quad, and that's here. So we know that Q1 plus Q2 must be equal to S1. Looking further into it, okay, let's write that. So this is also red. So Q1 or Q2, try and get them somewhere else. Try and stretch them somewhere else into the shape. So if I look at Q1 first, we were given that KP is a tangent. So if I take a look at Q1 first, I will see that Q1 is equal to, you look at this triangle here. So that's going to be equal to P1 because of the converse tan chord theorem. Where else can we go? Well, there's a looking at the information. Oh, okay. P1 is equal to R2. So where's R2? Here was given. P1 is equal to R2 is given. Then we have R2 is a triangle here somewhere. No, always try and look for where can we put R2 if we're just brainstorming stuff. Try. So R2 doesn't subtend because it doesn't come off a chord nicely. So don't make the mistake of trying to do this. Nope, that doesn't work. So for that reason, I'm trying to look at the triangles. I'm trying to see if it could be something else that we could use. There's no tangent there, so there's nothing. So here, T2 is an exterior angle to this triangle here. So triangle TQR. So that means the exterior angle is equal to the sum of the opposite interior angles. So R2 plus Q2 must equal R2 plus Q2. So this plus this must equal T2. But because, oh, okay, I think I cracked it now. I need one more color. So R2 plus T2 equals T. This T2 is equal to our required to prove. R2 plus is equal to Q1. So Q1 plus Q2 is also equal to our required to prove. Yeah, I'm gonna start that all again. I random erase noise. Okay. So from the beginning, we were required to prove that S1 is equal to T2. So first we said that S1 is equal to Q1 plus Q2. The reason for this was that it was the exterior angles of a cyclic quad. So just to put that in, S1 is equal to that. So exterior angle of the cyclic quad that was given, PQRS. Oh, wrong color. Once we've got that down, we will also figured out that P1 equals to Q1. P1 equals to Q1, and that's because of the tan chord theorem. Then we had that P1 is also equal to R2 because it was given. P1 is also equal to R2, and that was given to us in the question. Always go back and check the questions, especially if you get stuck. And remember, order matters. Like if you're reading the question, the order in which they give you the information is usually, it's presented in such a way that the order will help you. Then the final breakthrough is that T2. Where is our T2? Here, which we needed because it's equal to our original required to prove. T2 is the exterior angle, so it'll be equal to R2 plus Q2. T2 is equal to R2 plus Q2, and that's because of exterior angles of a triangle. And finally, R2 is equal to Q1. Which we already proved. Did we already prove that? R2 is equal to Q1 because they're both equal to P1 over here. R2 is equal to Q1. Okay. This is proven. Finally, therefore, T2 is equal to Q1 plus, instead of R2, we put Q1 plus Q2. And we knew that Q1 plus Q2 were equal to S1 because it was an exterior angle of the cyclic quad that was given. That was 10.1. 10.2. So these, it's either going to be prop theorem or similarity. Those are your choices. And I'm looking at these. The first thing I usually do is I try and figure out if it's prop theorem. And I'm looking at my picture here. It doesn't look like it's going to be prop theorem because there's no, I don't see any triangles that look like this. So for now, that's not going to be likely. So I'm going to go for similarity. And I'll try. Then if you're doing similarity, you got to figure out which two triangles are you working with? Which two similar triangles? The way I do that is I look at I knew that if we're doing two triangles, this was AD over AR is equal to AS over AC. That if you're doing proportion in triangles, then the top part will be from one triangle and the bottom part will be, wow, that's not a different color at all. The bottom part will be from another triangle. Okay. So one of our triangles has to use ADS, and that's lucky. So it's AD and S has to be in one triangle. And the other triangle that was from the top and from the bottom is ARC. A triangle ARC. So we're looking at these two triangles. That's how I figure out my triangles. That's how I figure out if I'm going for similarity or prop theorem. So these two triangles, let's get them highlighted. So ADS or ASD is here. We have to prove similarity between this triangle and ARC. Okay. ARC. So let's start setting up our similarity proof. So we start in triangle ASD and triangle ACR. So they both have the angle A. So we can just say angle A is common. Okay. And remember, when you're proving similarities, we're probably going to be doing angle. So similarity or sides in proportion. But since we don't know the sides, we're going to go for angle. So number one, A is common. Angle A is common. They both have it. Then we can see from our angle S1 here. So the next angle we want to go for. Well, it's equal to T2, which isn't very helpful. Okay, stare at that for a bit. What other information haven't we used yet? Well, I'm looking at all the information. The only piece of information that I haven't used is that parallel lines. So this is parallel to this. We haven't used that yet, so we still have to use that. So we have a C2 must be equal to T2. There we go. That will work. And because those are equal, the S1 must be equal to C2. So let's get that written up. So number 2 is that S1 was equal to T2, and that we've proven in the previous question. And then we have angle T2 therefore angle, it's not therefore, but just T2 is equal to C2, which we saw from the alternate angles. Alternate angles, and obviously always name your parallel lines. QS parallel to CA. Okay. And the third reason is just the third angle in if the first two angles of the triangle are equal, then the third angle is equal as well. So you've got your three angles. Because the three angles inside a triangle add up to 180, if the bigger triangle has the same angles, then if these first two are the same as each other, then the third one has to be the same because they're both going to add up to 180. So that's what I assumed for the third angle. Right, so therefore we have triangle ASD, and here order matters. So you start with A, and then you move to, we started on A, so then you have to start the same place on the other side. Similarity goes this way, similar but not similarity, 3 lines upwards. So ACR, so started on A on this side, and then we do S. S was the same as C, so C, and then the third one is R. Okay, now we can do all our proportions, and then I think we should hopefully, if you've chosen the right triangles, the hardest part in this is to choose the correct triangles. So because of this, AS over AC, as long as you get the order correct, so AS over AC is going to be equal to SD over CR, which is going to be equal to AD over AR. And for this last step, we just go back to our question and check. We wanted ADAR, so let's see if that's there. ADAR, and we wanted ASAC. ASAC, okay. So you don't have to, you could just, in your proof, you don't have to write this one as well, but I just, to be thorough. So AS over AC is equal to AD over AR, which is the answer. That was question 10.2. Question 10.3. So this fantastic looking thing. So we have to prove that AC times SD is equal to AR times TC. So there are a few things that I look at. I always look at, are we looking at prop theorem or similarity, or probably we're going to be looking at either prop theorem or similarity to work in this proof. And then I try and figure out which sides we're working with here. So one way I can work out what proportions we're working with is times cross divide. So I could, for example, say AC divided by AR is equal to TC divided by SD. And from there, well, I noticed that if we were using prop theorem, then this triangle ACR has become involved, because for prop theorem, the triangle is within the proportion. So it's top and bottom, A, C, and R are in there. So then I look, ACR is the purple triangle in the diagram. So I know maybe we're using triangle ACR, and there are some parallel lines in there. There's ST and there's AC. So that's what I start looking at. And then I see, well, okay, we have, let's give a fresh space there. So we have AC. Oh. And we have AR. So, okay, so then if it's AC and AR, it looks like it's not using the prop theorem, because prop theorem would go down one side of the proportion triangle. It would, AC and AR, it looks like it's using similarity. Well, let's quickly, just for interest's sake, see where our others, so where is TC and SD going to be? So TC TC is here, and SD is here. So SD is within the triangle that we were looking at before from the previous question. The TC is really an unknown. TC, we'd have to change to something else. Okay. So these sorts of questions, you either see them or you don't. We can, I've looked at this one beforehand, so we can just go through it systematically. So step by step. Okay, let's take a look. So AS is in proportion to AC from the previous question. So AS is in proportion to AC. So we can say AS over AC is equal to SD. So we've got our AC in there, not AR so far. And we've got our SD in there from the previous question. So SD will be over CR. In order, SD will be over CR. And that's because of triangle ASD is similar to triangle ACR from question 10.2. Okay, so we have this piece of information is a secure piece of information. Then we're like, oh, okay, we haven't got, that's not everything we need. So let's look at the prop theorem. So if we look at the prop theorem of the two triangles, then AS over AR is using the parallel lines ST and AC is going to be equal to, on the other side, let's put on this side, CR would be in the denominator. And what color did I use? CT. Okay. So I said we have AS over AR because of prop theorem equal to CT over CR. So just that's if this over this is equal to this over this prop theorem, as long as these lines are parallel. Your reason here is prop theorem TS is parallel to CA. Okay, so now I see that now we've got that AR somewhere. It's over here. And we've got the CT somewhere. So we're starting to kind of get all the components of our proof in there. Let's see where it's leading us. So that's, if we times these out and we get AS on its own, I'm going to get AS on its own, then AS is equal to SD times AC, SD times AC over CR, and AS is also equal to, that's from this one. Oh, there's lots of arrows going on there. Okay. AS is also equal, we're doing this one now, so CT times by AR over CR. I just rearranged these two to put AS as the subject. Where am I going with this? Well, if AS is equal to AS, then SD times AC over CR must be equal to CT times AR over CR. And we use our similarity and prop theorem for this question. Go back to our question. We were requiring to prove ACSD. So do we have AC/SD? We have SD/AC, so that side, yes. And we were required to prove that that is equal to AR times TC. Do we have it? AR, CTC, the same thing? Yes. We can just drop the denominators. Boom, boom, boom. Okay. So to put it in order, AC times SD is equal, therefore, to AR times CT. Fantastic. That concludes question 10 and also November 2022, paper 2. Good.